Assalamualaikum and a very good day. So today we are going to continue our lecture on the capacitance topic. Um, we are going to focus on the power and energy for a capacitance. The power delivered to a circuit element is the product of the current and the voltage. So P is equal to voltage multiplied with current I. So, and then we can relate the current with the capacitance formula. We know that current I is equal to capacitance multiplied with derivation of voltage with respect to time dt. Okay, so you substitute I into the equation, so you will get V C dV over dt. Okay, and then in order for you to determine the energy, okay, Wt, so you need to integrate from t to 0, and then pt dt. Okay. We do that integration of t0 pt. P is voltage, power is equal to voltage times with the current, Vi, then substitute I, okay, substitute I, T0 V C dV over dt. Okay, now integration for with respect to V, so you will get V to the power of 2 C over 2. Okay, then don't forget your integration from t to 0. Okay. So 1 over 2 is equal to C V versus. Now we try to solve this equation. First, we need to determine the current I is equal to C dV over dt. Okay. For capacitance, we know the value is 10 microfarad. So we need to differentiate the voltage over the with respect to time. Okay, so from the graph here, we need to get the equation that represent this graph. So we divide it by interval. This is the first interval, second interval, and third interval. For the first interval, from 0 t to 1 second. It will be in the form of voltage equal to m t plus c, which is equal to y is equal to mx plus c. It is a linear equation. So voltage is here is 0. Okay, so Vt, and then m will be its slope for 0 to 1 second, which is here at interval of 1 is 1. It will be 1000 minus 0 divided with 1 minus 0, which is 1000. It is for m, and then the intersection, which is c, is 0. So the equation will be, you can write the equation as 1000 t, okay, okay. Then for the interval, for the second interval, which is from 1 t to 3, okay, we can determine the slope m. Here is 3 1000. So 1000. Okay, 1000 minus 1000 is 0. Okay, sorry. And then the intersection is 1000. Okay, so the equation will be Vt equal to 0 plus, okay, the intersection is 1000. Okay, so it is 1000. Then for the third interval, which is from 3 t to 5, okay, here the coordinate will be 5 0, and then here is 3 1000. Okay, then is equal to m is equal to 0 minus 1000 divided with 5 minus 3. You will get negative 500. And then we need to determine the intersection. Okay, for this graph, if we project, it will be intercepted somewhere above here at the voltage. So the value of the intersection we will need to determine by using the ratio. Okay, so the ratio from 5 to 3, which is 2. Okay, if the graph move another 2, okay, this 2 here is equal to 1000. So if the graph move another 2, it can be, we assume it as 2000. Okay, so half of this 2, which is 1, the graph will move another 500. Okay, which is half of the 1000. So here it will intercept at the 2500. Okay, so the equation will be Vt equal to m, which is negative 500 t plus 2500 Therefore we can write the equation of voltage dt is equal to, the first equation is 1000t for interval 0 t1 1 second, and then 1000 for 1 to t to 3 second and then negative 500 t plus 2500 for 3 t 5 from the interval 3 to 5 okay. So the current will be equal to capacitor 10 microfarad times with the voltage Vt Vt sorry my bad, okay, times with dV over dt. So the value, the differentiation of 1000t is 1000, then 1000 is 0 dV over dt, then this will be negative 500, okay. So you will get 10 times 10 to the power of negative 3 ampere, 0 ampere, and negative 5 times 10 to the power of negative 3 ampere. Okay. So now we can draw the graph as like this okay. Okay. Current IT will be in milliampere why? Because it is time to the power of 10 to the power of negative 3. So here is, we assume it as 10, then negative 5 somewhere here. Okay, the first graph, the x-axis will be its interval t second. Okay, this is 1 2 3 4 5. Okay, from 0 to 1 it is 10 milliampere. Okay, and then 1 to 3 is 0 ampere, and then from negative 5 will be minus 5 milliampere. Okay, so the graph will look like this for the current. Okay, then now we need to determine the power delivered. Okay, power is equal to voltage times current. Okay, voltage, we can get the voltage which is here. Okay, voltage, okay, current is, okay, we write it as 10 times 10 to the power of negative 3, then 0, then negative 5 times 10 to the power of negative 3. It is for current. Time with voltage, which is the voltage is 1000 T 1000, then negative 500 T plus 2500. Okay, this is for their own interval lah. Okay, so I no need to write it. I will write it in the final answer. Okay, so it is equal to, okay, 10 T watt, then 0 watt, and then negative 5 times negative 5 times negative 500 will be 2500. Okay, then negative 5, negative 3 times 2500 is, okay, you will get a negative 12.5, 12.5. Okay, 12.5. Okay, here it is for interval of 0 T to 1, 1 T 3, then 3 T to 5. Okay, so for the first equation, from 0 to 1, the power graph will look like this. Okay, 10T, so 10T, okay, so it as 10, then this is PT watt. Okay, this is 1, 2, 3, 4, 5. Okay, then 10T, so it is a linear graph. Okay, this is for the linear graph, 10T. Then the 0 watt will be from 1 to 3. Okay, 0 from 1 to 3. Okay, now you will get 2500 T. Here is T. Okay. Sorry, here will be supposedly, okay, let me erase it. Okay, if you multiply -5 times 10 to the power -3 with -500, you will get you will get 2.5 T. 2.5 T, and then -5 times 10 to the power of -3 times with 2500, so -12.5. Okay. Okay. Here, in order for you to draw this graph, okay, you need to substitute the value of 3 and 5 in the equation. Okay. So let's say you substitute the value of 3, okay, in the equation 2. Okay, I will write it in the red. Okay, the red pen. Okay, 2.5 multiply with 3 minus 12.5. Okay, we'll get -5. Okay, -5, and then substitute with 5. Okay, you will get 0. Okay, so you can draw the graph. You can draw the graph, which is, let's say this is 5. Okay, this is -5. So the graph will be here -5, and then with the t value of 3. So somewhere here, and then for the second one it is 5 and then 0. So it's here. So the graph will be like this. Okay, this is for the power graph, t second. Okay, to calculate the energy, okay, with the energy equation is equal to 1/2 times with capacitance with, and then times with voltage square. Okay, we know the voltage square equation is from the previous equation. Just substitute the voltage equation into this equation, and you will get 1000 t square, 1000 square, and then minus 500 t plus 2500 square. Okay, then you simplify the graph, you will get a 5t square joule 5 joule, one and the final interval which is 3 t to 5, this equation, and then for the graph, okay, for 5t square it represents a quadratic graph. Okay, so substitute the value of 0, okay, and then substitute the value of 1. Once you substitute both value, you will get the y-axis. So for y-axis for interval of 1 is 5. So since it is a quadratic graph, so you will get this kind of graph. Okay, and then for 1 to 3, it is directly 5 joule, so it show a straight graph. Okay, straight graph for interval of 1 to 3. And then for interval of 3 to 5, you substitute 1.25 open bracket 5 minus t close bracket square equation. So similarly, you will get a value of energy 5 joule for y-axis. Okay, and then just plot the graph for each interval using the right equation. Okay, so you will get this graph. That's all. Thank you.